So, welcome to this lecture series on something that we are going to refer to as TOC. TOC is going to stand for total organic carbon. And this is actually called a TOC analyzer because it will analyze the TOC that's found in a sample that I present to it. So this is going to really be formally referred to as a TOC analyzer, but we're lazy. We don't like to say the word analyzer at the end, so we just simply call it TOC and we call it a day, right? Okay, so what we're going to do in this lecture series is we're going to talk about the TOC. What is it? How do we get it? Should we find it? Yes or no? Is it good or is it bad? And then we're going to take a look at the piece of equipment. And we're going to talk about how the equipment produces a signal that we are going to refer to as the TOC on that particular sample. Now, the actual instrument is fairly easy to use. You just really have to push one or two buttons and that's it. But there's so many working pieces that go behind the closed door, and we're going to talk about that. So in the first part of this lecture, we're going to talk about the theory of how the machine is doing its job and why is it doing its job and why are we looking for the things that we're looking for. And then number two, I'm going to talk about what I'm going to refer to as the main pieces and parts. All right. So these are the pieces and parts that have to be there in order for this machine to do its job. If one of these goes out, then you really can't do any number, any analysis or anything. And then number three are what I'm going to call the support features. And these are pieces and parts of the equipment as well that's there that allows it to do its job a little bit better, a little bit faster, a little bit quicker, and a little bit more reliable. So that's how this lecture is going to be broken down. And finally, number four, we're going to talk about the alternative methods. All right. What are some of the other options that are out there as far as this machine goes that allows me to still look for TOC, but maybe look for different things other than just simply TOC on a sample? So those are the four things that we're going to be talking about in this lecture series. And you're going to have quite a few videos that you're going to have to watch, maybe some assignments that go along with them to prove to me that you're not watching them all at one time, that you can actually go through a series of a couple, take some notes, complete an assignment, and then move on to the next part of the TOC lecture. All right, so here's the breakdown of what we're going to be talking about. There's also a chance, too, that you've used a TOC already. Maybe you've used the TOC in a different class. Maybe you've used the TOC at a place that you're currently working. I mean, who knows? Some of our students do come from a working laboratory facility right now. And if so, then I'm going to still tell you to go through these lecture videos and still watch them and still take notes, because there's a chance that I might say something that you just simply do not know. And if that's the case and you skip all these lecture videos and you go and you do the assignments, there could be a few questions there that you're going to get wrong, just simply because there were little tidbits of information that I've given you over this lecture series that you missed out on. All right. Also, at the same time, this lecture series will also be probably part of the final. So you know that it's coming your way. Make sure that you study up on this piece of equipment and make sure that you really pay attention throughout this lecture series, because this TOC instrument is an instrument. It's a very important instrument, and it's something that we want to get your hands on and get your knowledge behind. All right. Okay, so without wasting any more of your precious time, let's go ahead and talk about a little bit about the theory of the TOC instrument. But before I do that, I kind of want to show you a picture of what we are referring to in the laboratory first. And here you go. So this is a picture of the TOC instrument that we use in our laboratory. And the manufacturer of this piece of equipment is a company with the name of Shimatsu. Shimatsu is a Japanese company. They make tons of different analytical laboratory equipment that someone could use. And we have their TOC, but we also have their LC systems, and we also have their GC systems as well. What are those other systems? It doesn't really matter right now. You'll eventually get acquainted with those. But Shimatsu is a common brand or company that you're going to find in the chemical technology laboratory. All right. What you're seeing on the picture right now are two different pieces, but it goes to the same instrument. This is the main working instrument right here. So this is really what we're referring to. We're going to start talking about the pieces and parts of this TOC instrument, and this is what we're going to call an auto sampler. All right. The auto sampler I'll talk about in more detail in just a minute, but it allows me as an analyst to load up multiple samples at one time, and that way the auto sampler can inject those samples one by one, and I can really just walk off and leave this instrument and let it do its own thing. And then hours and hours later, I could come back, and then all of the samples will be analyzed, and I will have data for all of them on my computer screen. So the auto sampler is a very important piece of any type of equipment, especially if I'm working for a laboratory and that laboratory has multiple samples that have to be ran on a daily basis. Each one of these would require you to be there like every 10 minutes, and it will do triplicates. So every 10 minutes you would have to come back and you would have to load up the next sample, hit run, and go through that whole experience again and again and again and again. And that's really wasted time, especially if you forget about it. So the auto samplers allow you to load up everything at once. It will inject everything back to back to back for you. And we do have an auto sampler on our instrument at this point. So we're going to talk about both pieces and parts, and you're going to find an auto sampler too, more than likely, if you go out and you work for a company. So let's talk a little bit about total organic carbon. We've already talked about the abbreviation. The abbreviation is TOC, total organic carbon. And you know that's going to be a test question or an assignment question. What does TOC stand for? You know that it's coming. But it's actually a misnomer. A lot of people talk about total organic carbon and they focus on this word that says total. But the problem here is that when we talk about total, people assume that it is the total amount of carbon. And that is not the actual correct labeling for this, okay? Total carbon is actually abbreviated as TC in this world. So we have TC, which is total carbon, and we have TOC, which is total organic carbon. And, you know, quite honestly, we also have IC, which stands for inorganic carbon as well, all right? So inorganic carbon is IC. The TOC is total organic carbon that we're going to be focused on. And the TC is going to stand for total carbon as a whole. And actually, the organic side of the house and the inorganic side of the house add up, and that is how you get your total carbon from a sample. All right. Now, this machine is not going to look for total carbon. That is not what it does. This machine will only look for the organic part from carbon. That's it. So the inorganic side of the house, this machine does not normally look for. Now, this is a modification that I can bring into the system, and I can report values of inorganic carbon if I want to. But most of the time, on a routine daily run, we are looking for the organic portion. That's the total makeup of carbon. We are not interested in the inorganic side of the house. Therefore, we are not reporting total carbon. We're reporting total organic carbon instead. All right. Now, to make this even more confusing for you, under the organic carbon label, total organic carbon, there's actually two different versions. One version is going to be called non-purgeable, and the other version is going to be called purgeable. So purgeable, we don't really have an abbreviation for it, honestly. We just write purgeable on here. The non-purgeable is NPOC, non-purgeable organic carbon. And right here's the definition, and right there's the abbreviation. So again, you know that's going to be an assignment question. You make sure that you study that up, make sure that you know what it means, because NPOC is actually what we are really measuring in this instrument. Okay, so that makes this process even more confusing. So, total organic carbon analyzer, number one, doesn't measure total carbon. It measures total organic carbon. And in that total organic carbon, there's two classifications. And the one that this will focus on the most is the non purgeable part of organic carbon. It is not really measuring the purgeable part of organic carbon at all. All right. And one of the reasons is that this purgeable piece normally makes up less than 1% of the sample. So if I can just measure non-purgeable, then I really do have a representative sample that we maybe would trust in a analytical laboratory. And if I do want to go through and I think that it does have inorganic carbon that we want to report, I can still do that, but I only really do it if it's actually requested or if it's part of the general method that I have to follow. So we are measuring, bottom line, non-purgeable organic carbon. That is what this instrument is doing, all right? So that's the very first thing that I want you to take away from this. And again, you know that's probably going to be a question, right? Explain exactly what you're measuring with TOC. Well, you're exactly measuring the non-purgeable piece of the sample. So what does non-purgeable piece mean? Well, if you've ever seen the movie Purge, it's kind of similar, right? Non-purgeable, well, if you purge out something, you get rid of it, right? So the purgeable organic carbon, this machine is going to get rid of it because it's purgeable. These things are typically very volatile. They have very low boiling points. They evaporate off very easily. That's why it's very easy to get rid of it. Well, the non-purgeable piece, the NPOC, means you cannot get rid of it. So this machine will not be able to get rid of that organic carbon source. So once it does what it needs to do, it gets rid of all the purgeables, away they go, and then the non-purgeables stay behind. You can't get rid of them. They're going to stay there, and that's exactly what this machine will measure. All right? So just a little bit of maybe more concrete definition. TIC is the total inorganic carbon, and this is something, of course, now we know we don't really measure in the total organic carbon analyzer or the TOC. This is very low concentration. We can detect it if we want to. We can report it if we want to, but quite honestly, it's just rarely done, at least in our laboratory. So total inorganic carbon is the sum of the carbon that's present in anything inorganic. Okay, so I'm going to clear that definition up for you in just a minute. But these carbon sources are typically present in water, carbon monoxide, carbon dioxide, any kind of carbonate, hydrogen carbonate, that we would also call bicarbonate. That's another name for that, by the way, hydrogen carbonate and bicarbonate. Sodium hydrogen carbonate is the same as sodium bicarbonate. Cyanide, cyanate, and thiocyanate. And it says TOC instruments mainly detect CO2, and that originates from the hydrogen carbonates and carbonates, just like TIC. So total inorganic carbon. So we can measure it, we can report it, and it's just a different type of carbon source, which is why we put it into a different category. The next one is the TOC, and of course the TOC is the total organic carbon. And this is something that we say organically bound. So we're talking about organic chemistry and organic molecules here. So this is typically some type of matter, suspended matter, dissolved matter, maybe bacteria, that type of thing. All of that can be detected using this instrument. And it says cyanate and thiocyanate and elemental carbon are also determined. So it's just the way that these things react, and it's the way that these things behave on the inside of the analyzer. So cyanate and thiocyanate, they might be classified as inorganic, but at the same time, this machine will be able to pick those up and report them, which is another reason that we're saying that when we measure total organic carbon, we're really only leaving out 1% or less of the other carbon sources that might be found in that sample. So that's why we can get away with this most of the time, and that's why TOC is so focused on the total organic portion of the house. Now, I keep talking about organic and inorganic, right? So I'm going to come back here and we're going to clear out this screen. And on the periodic table, it will typically look something like this, right? And if you've taken General Chemistry 1 or General Chemistry 2, you might have talked about the staircase. That staircase kind of goes down like this. And that staircase is a dividing line. And that dividing line means that anything to the left of that staircase and anything to the right-hand side of that staircase are really grouped as two different types of atoms or elements, okay? So everything to the left is going to be classified as a metal, and everything to the right-hand side is going to be classified as a non-metal. Okay, so for instance, calcium is over here to the left-hand side. Well, that means that calcium is going to be grouped as a metal when it concerns to the elemental classification of it. And then over here to the right-hand side, you might see something like chlorine. And that means that chlorine is to the right-hand side of that staircase, and that staircase is going to let you know that chlorine is a non-metal. Okay, so whenever we group a metal and a non-metal together, so anytime something to the left-hand side of that staircase and anytime something to the right-hand side of that staircase comes together to give us a compound, we're going to call this an ionic compound. Okay, this is the world of inorganic, all right? So this total organic carbon analyzer really does not measure inorganic carbon. Okay, we said that we can attach things to it to get it to measure inorganic or inorganic carbon, same thing, but we just simply don't do it. Well, this is what is classified as ionic as far as structure goes. If you have all nonmetals, all right, all nonmetals, then this thing is going to be classified as a covalent structure. And that covalent structure is also a very good sign that this thing is a total organic carbon source. All right, so let me give you an idea here. Let's say that we bring in a carbon and a non-carbon based molecule. The non-carbon based would be NaCl, salt, right? All right, so Na, if you look on your periodic chart, would be over to the left, and Cl would be over to the right. So this thing is classified as inorganic. All right, well, that doesn't really even matter at this point because this compound does not have carbon. It has chlorine, but it doesn't have carbon. All right, so because of that reason, this NaCl doesn't have carbon, therefore it will not be measured in the total organic carbon analyzer. All right, so hopefully that will make sense. If it doesn't have carbon, you're typically not going to be able to see it in this machine. All right, so now let's take another compound, and let's make sure that this compound does have carbon. All right, so let's go through and just pick out something. So let's say C6H12O6. All right, so let's say that compound is inside of a sample, and I submit that sample to my TOC instrument. If I look, my carbon is over on the right-hand side, and there's carbon here, so that's a good sign that TOC could see it. The hydrogen, it's listed over here, okay, on the left-hand side. But hydrogen is the exception. Hydrogen is always going to be classified as a non-metal. You know, he never really finds a proper home on the periodic chart. That's the problem with hydrogen. And over on the left-hand side, everything else on the left-hand side is going to be classified as a metal, but hydrogen is not. He is going to be classified as a non-metal. So his home really isn't there, but it's a good place for him at the moment, and he's just always lost in life. Poor little hydrogen. That's just the way that he is. Okay. So hydrogen is going to be a nonmetal, and oxygen is over on the right-hand side. You're going to see oxygen over here as well. So this truly is a covalent molecule. It is not an inorganic one. So it could go into the category of total organic carbon. Yes, that is a possibility. C6H12O6 is actually glucose. All right, that is just your blood sugar, pretty much. I mean, that's all that is. All right. So this thing could be detected in a water sample using a TOC instrument because, number one, it is carbon-based. Number two, it is not classified as an inorganic source, right? There's no metals and non-metal mix. It's all non-metals here. So that is a good sign that it falls in the TOC category. All right, now, the next one is there's two classifications under this. NPOC, which is non-purgeable, and then the purgeable organic compounds, POC, all right? Or write out the word purgeable, doesn't really matter, but hopefully you'll know what I mean if I do write POC. Well, sugar isn't very volatile. I can put glucose out onto the, and it's not table sugar, by the way, but I can put this glucose, which is a sugar, onto a countertop, and I can sit there and I can look at it, right? Nothing's ever going to happen to it. It's not going to evaporate in front of my eyes. It's not going to disappear. So it's not volatile. It doesn't have a really low boiling point. It's a solid, all right? So this is not a purgeable compound. So when this machine does what it needs to do to my sample, the glucose is not going to go anywhere. The glucose is going to stay there, just like it stayed on my countertop. Therefore, this is going to be classified as a non-purgeable organic compound, NPOC. And that is really what this instrument pays attention to and is what this instrument measures. All right. Okay, so just to kind of give you a summary, this is kind of the breakdown. Maybe this will help you understand it a little bit better. So we're looking for total organic, or total carbon, sorry, up here at the very top. And total carbon is going to consist of the total organic carbon and the inorganic carbon. I have to have both sides of the story. Okay. The inorganic carbon, we now know how to determine if something's inorganic. Metal and nonmetals, based on the position of the table. If it's classified as inorganic, this instrument's probably not going to pick that up. The total organic side, we now know how to determine that. If everything is nonmetal across the board, it's a very good sign that it's organic, covalent, carbon-based. And then under that category, there's those that are purgeable and those that are not purgeable. All right. So non-purgeable is NPOC and purgeable is POC. So that is the breakdown. The TOC instrument actually is just measuring this. All right. Now I know that TOC up here at the top branches off into those two categories, and that is true. It does. But my TOC instrument and the common TOC instrument is really only measuring the NPOC levels. And once again, the reason is the purgeable content is normally less than 1% of that value. So that is why we just don't simply waste our time on measuring that portion of the sample unless we absolutely have to. All right. So when I put a sample onto this instrument, my sample will run through the instrument automatically, but my data only represents non-purgeable. It does not represent anything else on the screen. It does not represent really purgeable organics. It does not represent the inorganic carbon. And of course, it doesn't represent the total carbon up here at the top. It only represents NPOC levels. And that is it. No more. Okay? Again, unless I make a modification to my machine, a modification to how I want it to see things, this is the only feedback that I'm getting from the instrument. So once again, This is the instrument that we're looking at. My TOC instrument's to the right-hand side, and my auto sampler is to the left-hand side. So in the next video, we'll talk about why I would use this in a laboratory in the first place. Now that we know a little bit of background about what we're after, we need to talk about where and what form would it come in. This non-purgeable organic carbon? Really, what are you talking about here? Why is this so important? You'll learn that next.